The diagnostic engine inside the Fluke 810 has been developed over the past 30 years to follow the same steps of an experienced vibration analyst. In the first step, we need to find the actual speed of the rotating shaft. Based on the target speed given by the user during the setup, the diagnostic engine looks for the largest peak inside a plus or minus 4% window. This is seen on the graph on the right. The largest vibration typically comes from the large, heavy mass of metal rotating at, say, 600 RPM. In the graph on the bottom left, we see a peak at 600 RPM, a peak at 2400 RPM, and a peak at 4500 RPM. The diagnostic engine is told that the machine speed is 600 RPM and identifies the peak at 600 as the vibration from the rotating shaft, as you see on the graph on the right. It then takes information that is 4 impeller vanes, sees a peak at 2400 in the data, which is 4 times 600 RPM, and identifies this as the 4 impeller vanes. Step number 2 is to generate a synthetic baseline. This is performed every time a measurement is diagnosed. From the information selected by the user during machine setup, the diagnostic engine searches its database compiled over 40 years from hundreds of thousands of machines to find what a machine of the same category would look like. In the graph on the left, we see a low red line that reflects the baseline level selected for this machine. Notice that in the lower frequencies, over to the left, the alarm level is higher because noise levels are higher in low frequencies. Also notice that the baseline level is raised to cover the peak at 1x because we expect a larger vibration to be seen from the shaft vibration. We found this in the previous step. We're also going to have increases at the harmonics of the shaft vibration. The graph on the right shows the data from a typical healthy machine, and notice that those peaks would all fit underneath the baseline on the left. You will notice that on the graph on the left that there is a peak that exceeds the baseline. This is an anomaly that we need to find a fault or reason for this. We'll do this in the next step. In step number 3, we compare the exceedances of the baseline to 4,700 rules. Of these 4,700 rules, there are 4 common faults that we see every day: imbalance, misalignment, looseness, and roller bearings. We'll focus on these 4 faults in the 810. Here's an example of the pattern that we would see from a roller bearing. Notice we see the 9 stages of roller bearing wear. We don't need to analyze the data because a diagnostic engine will do this for you. These rules are built into the Fluke 810. You can watch the machine fault go from slight to moderate to serious to extreme. At the last step, we see the results of the diagnostic report. The diagnostic engine found the shaft speed, developed a baseline, compared the exceedances to 4,700 rules, then gave a report with the fault, with severity, location, and recommendation. For more information, we would look into the viewer software to review the data.